My name is Birgir Óskarsson. I'm a geologist at the Icelandic Institute of Natural History. Today I'm going to show you how we place the ground control points for the photogrammetry surveys. Alright, what we do is that we place targets around the volcano. Targets that look like this. We measure these targets with a precise GPS instrument. So we get centimeter precision on the position of these targets. And these targets are actually then seen on the photographs that we take from the airplane. And then we can find the accurate position of these targets on the models and georeference them very precisely. Yeah, this is a precise GPS instrument with an antenna and a computer that connects to the antenna. I use a virtual base. Actually, I connect it through a hotspot. I connect the screen to a virtual base where we get the corrections for the measurements. Now, working in a dynamic environment like this has many challenges. Many of these targets that we have been using are now underneath the lava flows. They are buried. And so we had to replace them and position new ones. And this is one of them that we had to replace. There's one on the other side here, and there's the other ones on the top there, and all around the lava field. And some of them get burnt by the fires, the moss. So it's a very dynamic environment. Okay, so now this target has been measured, the position of it has been measured. Now we leave it and we will fly over, take pictures of the eruption area, and this target then will be seen on the photograph, or several of them, and we can then georeference the models knowing the accurate position of this target. Alright, so today we are going to fly over the eruption site and we are going to photograph the lava fields. We're going to fly with this ultralight aircraft, high wing, one engine from the Ultralight Aircraft Association in Reykjavik. And we are going to photograph using this camera, a Hasselblad A6D 100 megapixel camera, medium format, with a fixed 35mm lens. And we are going to place it in a hole in the aircraft and photograph vertically. Yeah, one of the good things about this method is that we can use any aircraft. We can fly with an open window and photograph oblique with a handheld camera, but we can also use a hole in the floor and then photograph vertically, which is what we have done mostly. Okay, the way I've installed the camera now for vertical photography is for manual triggering. So I have the trigger and I just manually trigger each image. And this is kind of the fast and light setup that we have for this camera. So I sit here and I control the camera while the pilot flies the aircraft. But we also can use a computer to trigger the images automatically. And we usually use it then setup in larger aircrafts. And in the photographs that we take, both vertical and oblique, we can then identify the targets that we placed the other day. And with accurate position of the targets, then we can georeference the models that we produce and the DMs. Okay, we usually try to fly as high as possible and usually go up to 2,000 meters. And at 2,000 meters we can fly then 2 or 3 flight lines over the lava field and cover it entirely. But in difficult weather conditions or low clouds, we fly lower and then we have to fly more flight lines to cover the entire lava field. Okay, when we fly there are many challenges, and one of the challenges is weather. It can be high winds or low clouds, and Another challenge is the eruption plume. Sometimes the eruption plume is big and we have to fly around it. There's also hot upwelling of air and turbulence, which we have to be aware of. And so there are many challenges flying around a volcanic eruption. Okay, the strength of this method is that we are working with lightweight cameras, which means that we can very quickly run into the aircraft, install the camera, and fly to the eruption site. And because we fly high, we need only 1 or 2 flight lines to cover the lava field. And then in less than an hour, we are back. And shortly after that, we are starting to process the data.